Today we're going to be working through a senior maths challenge question, and it has 3 circles contained in 2 parallel lines, and they're tangent to everything they touch. So the large circle, we have to figure out the radius of it in terms of the radius of the small circle and the medium circle. So first I'm going to plot the centers of these and join them up using the 2 radii. So I'm going to call the radius of the larger circle R, and the radius of the smaller circle S, and the radius of the medium circle T. Now the distance between these 2 centers will just be the sum of the radii. So I can write that as R plus S, S plus T, and R plus T. Now the key to unlocking this problem solution is to think about the distances from the center in its horizontal and vertical components. So I'll show you by adding these extra lines. So I've split the distances up into its horizontal and vertical components, which means that this angle here is a right angle, so this shape I've made is a rectangle. So I need to figure out the length of this rectangle and the height of this rectangle first. To do that, I'm going to extend the height so it touches the 2 parallel lines. Now if you notice, the distance from the center to one of the parallel lines is just the radius of this bigger circle. So I can just label the R. And this angle here is a right angle, since the angle formed here is a right angle due to the fact that this shape is a rectangle, and angles in a straight line have to sum up to 180 degrees. So that means that this smaller rectangle, the smaller shape here, is a rectangle, and this height of the rectangle is the radius of the medium circle. So I can just map this directly onto this segment here, and we can figure the length of it, which is just T. Now if I want to get the length of the shorter segment, I'll just take the difference between the large circle's radius and the medium circle radius to get R minus T. I can do the same for this side here. It'll be S due to the fact that this is a smaller rectangle formed, and the difference between the larger circle's radius and S would be the length here. So we found out the height of this rectangle. So next we have to find the length of the rectangle. To do that, first I'm going to label some of these segments. I'm going to call this here A, call this B, and call this whole segment here C. We can use Pythagoras to write expressions for these values that I've just labeled. So first, let's focus on this right angle triangle here. So I know due to Pythagoras that a squared plus b squared equals c squared. So that means that c squared plus r minus t squared is equal to r plus t squared. Now I can just rearrange that to make c the subject, and I get this expression here. Now if you look closely, this follows the structure of the difference of t squares, which is an identity that states that a squared minus b squared equals a plus b times a minus b. And a and b in our situation is r plus t and r minus t. So I can just sub in these values into this identity, and I get a new expression that is equivalent to the original one we had. Now I can combine the like terms, and I'll get this. If I multiply it out, I get c squared equals 4 times rt. Now to find c, we simply take the square root of both sides, and we get 2 root rt. We get 2, not 4, because 4 is a perfect square, and we can just take it out of the square root by square rooting 4 itself. And the reason why we only get one value for the square root is because lengths are positive, not negative. So it can't be minus 2 root rt. So I'm just going to store this value here for now, and let's focus on this next triangle. We do a really similar process to this, and we rearrange Pythagoras to make a squared the subject. We use difference of t squares to rewrite the expression. We combine the like terms, and we get that a squared is 4 times rs, and we square root both sides to get a equals 2 root rs. I'm just going to store this value here. And finally, let's look at this right angle triangle. So we've got this leg, we've got the hypotenuse, but we haven't got this leg yet. But the good thing is we can figure this out, because this whole shape here is a rectangle. So the length of the height here is equivalent to the length of the height here. And that is just the sum of these two segments we worked out earlier. So it'll be 2r minus s minus t. So we can rearrange Pythagoras again to get this expression. And we can use the difference of two squares to write it. Now we need to combine like terms, and we get this. Now I could expand this and then factorize it, but it'll be quite easier to just factorize the 2 from this parenthesis now. So I'm going to take out the 2. So I'll get 2r multiplied by 2 brackets inside the brackets, s plus t minus r. Now the 2r can just multiply with this 2 here, and I get b squared equals 4r times s plus t minus r in brackets. Now I can take the square root of both sides, and I'll get 2 root r times s plus t minus r, since 4 is a perfect square. So I'll start this. We've successfully got all three values here. So we got a, b, and c, and now we can do some algebra to figure out the answer to this question. So if we just look at this rectangle here, the a plus b is equal to c because they're both the lengths of the rectangle. And I'm going to write this down here. Now I'm going to rearrange this slightly to get that c minus a equals b. Now the reason I do this is because at one point we have to square one of these variables. So if I square a plus b, it'll be quite messy because both of these square roots are quite complicated. But if I get b on its own, then it'll just cancel out the square root, and I can just deal with a and c separately. So that's why I rearranged it. Now if I sub in these values into this expression here, I get this equation. And it has a common factor of 2 first of all, so I can just divide everything by 2, and I'll get this equation here. Now there's another common factor that might be harder to see, and that's root r. The reason is because square roots can be written as multiplication. So root rs is equal to root r multiplied by root s, and I can do that with all these square roots. And if you see, you have a common factor of root r, so I can just factorize the root r. Now since r has to be greater than 0 because it's the circumference of an actual circle, we could just divide by root r, and we get this equation here. Now this is quite good because we can just square this square root and we'll get rid of it, and I can square this side, we'll make double brackets. Now if I expand the double brackets eventually, I'll get this expression here, and these two cancel out, so I just get s plus t minus r. Now I can minus s from both sides and minus t from both sides to get minus 2 root st equals minus r. And we've basically got the answer here, because if I multiply the equation by minus 1, I get r equals 2 root r equals 2 root st. And that's the solution for this question. Thank you for watching, and I hope you found this video useful.